Our last and final INB is creating a rational function given a picture of a function. So a couple things to notice is I have a hole over here, and that looks like it's at 1, 2, comma, -1. I have a vertical asymptote at x equals -3, and I have a y asymptote at y equals 1. And so we just need to put that together. And what do I have and I also have a y-intercept at 0, 2, and I have an x-intercept at 0. Okay, so the first thing that I know is I have a vertical asymptote, x equals -3. So I know I have an x plus 3 in the denominator. Next thing that I know is I have a hole at 2, x 1. So that would be at x minus 2. And then that -2 would also have to repeat in the numerator so that it would be a hole and reduce out. I also know that I have a x-intercept at 6, 0, and that is the 0 of my numerator. So now I need a factor of something of x minus 6 up here. Okay, and then I know that I have a y-intercept at 1. Okay, so let's look at these two things. So one thing I could notice is my hole, so I reduced it out. I'm left with x minus 6 over x plus 3. I know I have an x-intercept at 6. I know I'm left with a vertical asymptote at 3. I know my y-intercept would be 0 minus 6 over 0 minus 3, which as of now would be, oh, this is a plus 3. And that would be a -2. And that's where my y-intercept is. And so everything matches up. I'm just going to check my horizontal asymptote. So my horizontal asymptote, I would have a second degree on top and a second degree on bottom. So I would have the same degree. So that means it's the leading coefficient. So if I multiply my first together, I'd get x squared and then some other terms, and x squared at the bottom, some other terms. And both leading coefficients would be 1. So I'd have a horizontal at 1. So it looks like everything that I've created so far is perfect. X minus 6 times x minus 2 over x plus 3 over x minus 2 is my function. And I could write it out in expanded form if I wanted to. This would be x squared minus 8x plus 12 over x squared plus x minus 6. And there's my 2 second degree polynomials. The second one looks like I'm going to graph and then do the work. So I'm going to have create a function with a vertical asymptote at x equals -1. I'll put that up there. A hole at 2. Don't know where that's going to land quite yet. And a 0 at x equals 6. Right here. And let's draw a graph. So the first thing that I want to do is I want to say y equals, have a vertical asymptote at x equals -1. So that's going to be an x plus 1. I have a hole at x equals 2. So I have an x minus 2 on the top. And I'm going to need an x minus 2 on the bottom and top. So that x minus 2 reduces out, creating a hole. And then I have an x-intercept at x equals 6. So I have a minus 6. And I think that's it. So if I wanted to finish and graph this function, there would just be a couple of other things that I'd want to do, but I'm going to write this one out so far. I think I meet all the requirements. And I get x squared minus 8x plus 12. And then on the bottom, I get x squared minus x minus 2. So same degree, second degree, second degree. Leading coefficients are 1 and 1 again. So I have a ordinal aspect at y 1. Sometimes, a lot of times, the leading coefficients are 1, so we get confused and we think sometimes when they have the same degree that it's always going to be 1. It's a popular happening, but remember, it's where the leading coefficients divide, even though 1 happens a lot. Sometimes we can get messed up when it's something besides 1 divided by 1. Okay, and then my next is, what's my y-intercept going to be? Y-intercept is going to be my constants divided by each other, just kind of like in a polynomial when it was just its constant, because everything else is going to 0. So I have a y-intercept this problem at 0, -6. And if I have a hole, if I reduce my 2's out, I have x minus 6 over x plus 1. And then I'm going to plug that whole value in of 2 to find the y value. 2 minus 6 over 2 plus 3, which is a -4 fifths, so almost -1. And so I now have a hole at 2. And then now after plugging it in, I get -4 fifths for the y. And it's easy to tell that it's going to look like this. And then the next thing that I want to do is just finish my graph. I know it ends up at the top. And it's going to finish up at the other corner up there. Okay, and that's how you build a function from a graph. You have 3 Desmos to be done sometime by the end of the day, Tuesday, beginning of Wednesday. Thanks. If you have any problems, just request a Zoom with me, and I'll talk to you then. Bye.